Hello folks and welcome back. Today I want to talk about the electrical system that I implemented into our Lockheed Vega. And for that, let's jump into the cockpit. On the right cockpit wall, you'll find the very basic electrical system of the Lockheed Vega. It consists of the master battery switch on the right side here, and a fuse box on the left side. And the fuse box has installed an ammeter, as well as all the various switches for the lights and the generator. You can open the fuse box by unscrewing the butterfly screws and then drawing the lid down. And here you've got access to all the different fuses of the electrical system. There's a wiring diagram on the lid that gives you an indication which fuse is for what. But you can also just hover over any of those and it will give you a little tool text that gives you the name of the fuse and its status. And for those of you who don't know how these fuses work, because this is kind of an old school technology. I mean, you'll still find them in some older houses, but nowadays usually those are being replaced by circuit breakers. And of course, in aircraft for a long time, circuit breakers are in use rather than these cumbersome and complicated fuses. However, this is an aircraft from 1926, so fuses were still a big thing. And so they're implemented here. And the way these fuses work is they consist of little glass tubes with a wire on the inside. And this wire can have a certain maximum current going through it. And if the current is reached, then the wire itself will melt. It will basically evaporate, and thus opening the circuit and making sure that the attached components and your battery are being safeguarded from high currents to go through it. And all of that is part of the simulation of the electrical system here. Before I started this flight, I went ahead and triggered some malfunctions using our persistency file. So the persistency file has all the variables listed that are being stored at the end of every flight. So when you exit the simulator, then this file is generated and populated. And when you load the Lockheed Vega the next time, all these variables are loaded back into the simulator. And I used this to trigger some of the malfunctions. And if you're a customer of the early access program, you'll get access to our debug panel. If you press Shift and 9, the debug panel opens. And here you've got a good overview of all the different variables that are involved. If you can click through different sections of that. And here is the electrical system. And you can already see in red there's some of these mistakes or malfunctions that I triggered. But let's start on the left side. On the top page here, you've got all the different parameters of your battery. It's a 12-volt battery, since the electrical system is rather simple and rather crude. It doesn't require much more power, and so it's just a 12-volt battery that, by the way, is situated under the seat. You can see that if you go a little bit down here. There's our battery. So there's a couple of parameters that are associated with the battery's overall health. The main one being the battery max charge. This is essentially the capacity, the maximum capacity that your battery has. It's a variable that is initialized the first time you load up the aircraft. And every time that you are replacing the battery, this battery max charge will be determined again. In a future update, there will be a wear and tear module that will deteriorate the battery over time, and this will affect the max charge that your battery holds. So as you know, that as batteries get older, their performance gets worse and worse. And if you have an old car, you know what a hassle it is to have a battery changed. This is part of our simulation here as well, but as I said, at the moment it's not implemented yet. The battery charge is the current charge of the battery. So this is how much electrical charge a battery holds. So at the moment you can see that our battery is rather healthy. We've got, and almost fully charged, we've got 42.1 ampere hours stored in the battery. And we've got a healthy battery voltage of 12.5 volts right now. The next thing that you see is the battery current. So this is all the current that is drawn from the battery at the moment in time. And even though our master battery switch is currently in the off position, the battery current is still minus 0.2 amps. So 0.2 amps are being discharged off the battery at any moment in time. And that is due to the parasitic power drain. You can see this down here. So down here listed are all the different electrical sinks. So where all the different components that actually draw electrical power from the battery. And while the battery master switch is currently off, that means that everything is switched off and nothing is drawing power. However, the parasitic power drain number 1 is always on. And that is to simulate the discharge of the battery over time, because as you know, you can't store a fully charged battery for a long time because it will discharge by itself over time, and that is simulated with the parasitic power drain. Parasitic power drain number 2 is there to simulate a further drain once you switch on the master switch. So if I turn this on, you will see how the current of parasitic power drain number 2 went to 0.15 amps. So currently all the fuses seem to be in working order. Everything is fine. But we also know that I triggered a couple of malfunctions. And one of the malfunctions is the cabin light. There's a short circuit in one of the cabin lights. And you can actually observe what happens by turning on the power. And now let's switch on the cabin lights and see what happens. What you saw is a very erratic behavior of the ammeter, and that is due to a high discharge. So there's a lot of current flowing through the ammeter, coming from the battery, through the fuse, through the light, because it's short-circuited. However, once this is triggered, you can see how the fuse is now blown. So the fuse protects the cabin light, and in fact, the cabin light is off right now because the fuse opened the circuit, and thus protecting both the battery as well as the components that uses the fuse. And now let's turn off the switch again. The way that you can change the fuse is a simple click. So you see cabin light fuse is blown. The first click will remove the fuse. Now it's open circuit here. And if you click again, one of the fuses from your spares is moved into the terminal and installed. However, if I turn on the lights again, you will see the same thing happens again. Of course, because there's a short circuit in the cabin lights. So how do we go about fixing this? If you press Shift and 3, you'll see the overhaul manual of the Lockheed Vega. And this is a very comprehensive tool that is still in development. So there's a lot of things that are not fully functional just yet, but you can see where this whole thing is going. There's various chapters. Some of them are still empty. However, all the systems that are implemented already are populated. So if you click, for instance, on the electrical system here, you will see a wiring diagram. So this is the very basic wiring of the Lockheed Vega's electrical system, and you got a list of components on the right side here. And we know that we have a problem with the cabin light. So if you click on Inspect, this will ask your mechanic Jack to check the cabin lights, and in fact, there's 2 problems with the cabin lights that he detected. The next thing you do is you can click on the report card, and this is the report card. It will give you a little picture of the component, if available, the name of the component, and there's supposed to be some text coming here, but that is still under development. So this will, at a later date, give you a little bit more of an insight as to what's actually going wrong with this component. And the next thing is you can ask your mechanic to fix the problem. And again, the job is queued, he's working on it, and it looks like he fixed the problem. You can also just click on the button here that says Inspect All Components, and that will queue all the different components at the same time. And so your mechanic will now work one after the other and will find mistakes, hopefully. And one thing that he found is that the cabin light fuse is actually not intact, and we know that the fuse is currently blown. So that is something that he can take care of as well. He also found a problem with the oil pressure warning light circuit. And there seems to be a problem with the booster coil as well. So once again, you can click on each individual component here. That opens the report card. Here we see the booster coil, and again you can click the button Attempt to fix the component. The other option is you can simply ask him to fix everything that he found, and so everything, every component where he found a problem is now queued to fix. So the first thing is that he replaced the fuse. At the same time, he will have replaced, he replaced all your spares because you were running low here. And now everything seems to be fixed. However, you must be aware that your mechanic is a human being. At least he's programmed to mimic the behavior of a human being, and he is fallible. So every single problem that can occur has 2 variables attached to that. One is the detection rate of a problem. The other one is the fixing rate of a problem. So with every single problem that you encounter, there's a certain probability that your mechanic might not find the problem. The other thing is that he might have found the problem, but he doesn't know how to fix it, or he tried to fix it but wasn't capable of doing so. And this is there to give you a feeling of really flying the real deal. It's just like in real life. You might have a problem with your car. You go to the mechanic says, oh yeah, I fixed this and this and this. However, you'll take your car, drive again, and you'll find out, well, the problem still exists. So the same is happening here, is that certain problems might not be detected, certain problems might not be fixed on the first round. So you have to go to him again and try to fix the problem that way. But let's just check the debug panel, because we can cheat. Unlike in real life, we can actually see what's really going on. And but it looks like the mechanic did a good job this time, so everything, all the systems seem to be working right now. And so indeed, if we turn on the cabin light now, you can see that that the ammeter seems to be okay, and if we jump into the cabin, you can actually see the cabin light is working. And that concludes our short introduction to the electrical system. There's a little bit more to say, but I leave that for you to find out once the Lockheed Vega is available for your purchase. So thanks for watching, and bye for now.